Okay, yes. I would like to thank also that I have the opportunity to talk today in this online meeting. And yes, I want to talk about spatially resolved light and color measurement technology. And as I heard already in this meeting, you are all very keen to develop lighting technology, everything which is luminous. And of course, this is good for us because we want to measure the light. Um, Yeah, Technoteam is a manufacturer for imaging, light, and color measurement systems. Uh, we are roughly about 65 employees. We have a lot of square meters of lab and office space. And we are located in Ilmenau. It's a nice green countryside in the middle of Germany. We are also very active in different committees like DFN, DIN, and so on. So we want to support research and development. As you can see, our customers are spread throughout the world. So we need to establish a good network in the world to support our sales and support network. So we have a lot of different companies, which are our distributors, and they do sales and technical supports in their countries for us. So why would you want to use an imaging luminance measurement device? So you can do objective quality assurance. And we are here to talk about automotive lighting. So I want to show you the interior of the car, for example. There are a lot of different areas which are luminous and of interest, of course. The display, for example, symbols, and also light guides for ambient lighting. And they all have different characteristics and also different values which are of interest, but also they have a lot of similarities for measurement. And one example is the homogeneity. Homogeneity is measured in displays, for example, white and black uniformity, and also for symbols, so that you can make sure that the whole symbol is really there and it's uniform. And for light guides, because they are so big, the homogeneity is important so that on the right side on the car is the same luminance than on the left side of the car. So, but for the objective measurement is even more important in the exterior part in the automotive industry, because here you have to measure according to legal regulations. As you can see here on this laser pointer, on this low beam distribution here, there are these points according, for example, the ECE regulation, and yeah, they have to fulfill legal regulation values. So the challenge here in the exterior area, that it's according to law, and we do not only measure the luminance, but we have to measure the luminous intensity. So it's a different photometric value. And to realize a different photometric value, you also have to realize different kind of measurement systems. For example, here you will have a whole laboratory with a kind of measuring wall, and in a certain distance of this measuring wall, you will place your headlamp. And of course, somewhere here in the lab is our camera installed. And as you can see here on the little labels, because of this whole setup and the knowledge about this whole setup, you are able to transform between different photometric measurement values. And here, this is the luminance intensity you want to have for headlamp measurement according to ECE, for example, ECE regulation. If you want to measure smaller modules, you can also have this whole technology in a little box, which is not as big as a whole laboratory. Since here there's an additional optic, and this additional optics realize a way shorter measurement distance of about 1 meter. By the way, this laboratory here is about 10 meter maybe, or maybe 25. This is flexible, but very big. Yeah, so here's this low beam distribution again. And what you can see here, or what's the typical characteristic of a low beam distribution, is that there's a lot of bright light and there's very less light, so very bright and very dark. So it can be that within this one image, within this one distribution, there is a high contrast. So, but what's with this high contrast? Unfortunately, very high contrast measurement is a shortcoming of an imaging luminance measurement device. Because as you can see here in this video, is it still working? There will be an offset caused by scattered light. The light is not perfectly transmitted through the system, but it will be scattered at lenses or housing parts or anything what's inside. And for a lot of measuring tasks, this is, of course, disturbing. And what you can do to reduce it, you can optimize your hardware. For example, by adding anti-reflection codes or making a lot of effort to initially choose from the lenses and the materials to use for building the camera. As you can see here, anti-reflecting coating on every lens and every surface and every glass which is inside. But it's not enough to realize a high contrast measurement. So we added an additional correction called stray light correction. And so we do an additional calibration and add this to our systems. And to show this example again, so you see here this automotive LED. And these LEDs are very bright, but they have to be very dark in the background also. So a standard ELMD will show you an offset in the background. And with the high contrast optimized ILMD, you can measure your values in the background better. And it's the same case for not luminance measurement, but for the luminous intensity measurement. So if you here have a low beam distribution, you will have approximately, for example, 30 candelas in the dark zone. But with a contrast optimized system, you will be with 3 candela more in the, I don't want to say correct area, but maybe you know what I mean. Yes, so that's my presentation. I hope you learned something new and listened to something interesting, and maybe you have some questions for me.